Welcome to Algebra 2, the most important questions. Let's get it. All right, question number 1. We have a long division question, and this is also an equivalent question. So if you have a brain fart, you can use your calculator, the calculator trick where you store in a number. So my favorite number is 10, so I would do 10 stow x. You can plug in the original, and then you can plug in all the choices and to see which one is equivalent. But I am going to actually do it the long way, just in case this is not a multiple choice question. All right, so let's set this up. And our goal is to figure out what times x gives us x to the third. So we are missing x squared. So you should always get the same exact thing as what's underneath and all the way to the left. Once you do that, you also are going to multiply by whatever that second term is. So x squared times 2, and you're going to put it right next, oh, this is supposed to be squared, to that x to the third. Okay, once you do that, it's time to subtract. So just so you know, the 4 steps are to divide, multiply, subtract, bring it on down, and bring it on back. So when you subtract, this should always cancel out, and when you subtract, all the signs are going to change. So in this particular question, 2 minus 2 actually does also cancel out. So when we bring it down, we really are only bringing down the x. And when we start over, we're now looking for what times x gives us x. Well, the only thing that gives us ourselves is 1. So 1 times 1 is x, and then 1 times 2 is 2, and in this particular question we're also going to bring down that 6, and now it's time to subtract. And when we subtract, that first term should always cancel out, and then that second one should always change the sign. And 6 minus 2 is 4, and then whatever our remainder is, we're going to go ahead and bring it on the top, and you always want to add or subtract that remainder and put it over whatever you divided by. So that looks like it is choice 2. Awesome. All right, the next question. This is a remainder theorem question. So in order to be a factor, you're plugging in a number. And when you plug in a number, in order to be a factor, it should equal 0. So right away, I know that if these are factors, it has to be equal to 0. Okay, now, when you plug in a number, it should always be the opposite number, which means that x plus 1, you'd be plugging in negative 1. X minus 1, you'd be plugging in positive 1. So if you look at choice 3, you're not plugging in negative 1, you're plugging in positive 1. That does not make sense, so that's not the answer. And for choice 4, you're plugging in 1, which does make sense. So by process of elimination, this is the correct answer. Now, if this was a free response question and they wanted to know, is x minus 1 a factor? How you would figure that out is you would actually substitute in 1 into your polynomial, and you would check to see if this is equal to 0. Now, because choice 4 is the answer, I know that this is equal to 0, which means that x minus 1 is a factor. Okay, let's move on. algebraically determine the zeros. Now, there's a couple different ways to do this. One way is you can use your calculator, which I do want to show you that briefly, just so that you know that if you can't do this algebraically, you can get half credit if you use your calculator. So zeros are where they touch the x-axis, where the graph touches the x-axis. So if I go to my y equals, let's plug in the equation. Okay, so I can either look at it. Okay, so it looks like it's crossing at -4, -1, and 1. Or I can go ahead and look at the table. And I'm looking for where I see 0. So it looks like x is -4. It looks like x is -1. And it looks like x is 1. So I'm going to just write that kind of on the side. Looks like x is -4. Looks like, actually, you know what? I'll do it over here because I'm going to show my work over there. X is -4, x is -1, and x is +1. All right, so if I do that, I will automatically get half credit, okay? Now, how do I get full credit? Well, this is the split method because I have 4 terms, and whenever you have the split method, that middle sign is always going to drop down. And then you're looking for what's in common on the left side and what's in common on the right side. So I notice that I have a 3 and an x in common on the left side. So when I figure out what's left over, I have an x squared plus a 4. When I figure out what's in common on the right side, I have a 3. Ooh, interesting. I have a 3 and I have an x minus 4. Okay, so I'm looking at this and something is going on. And the reason why I know that is because whatever is in the parentheses on the left side is supposed to be in the parentheses on the right side. So I do know that this should be a plus sign because, oh, I know what I did wrong. Okay, so I'm so glad this happened because whatever's in the parentheses on the left side should be on the right side. And I know what I did wrong because if I look carefully, I have a 3 and a 2 here, and I only pulled out x, which is incorrect because I really should have pulled out x squared. And now I should have x plus 4. Okay, so now that makes sense. So I'm actually really happy that that happened because that could happen to you as well. All right, so from here, you take the outsides, you smush them together. You take the insides, you smush them together. Now, on the left side here, I notice that I have a 3 in common. So I'm going to pull the 3 out, and I'm left with x squared minus 1. Now, x squared minus 1 is actually dots. And dots can be factored again. So I still have a 3. I have x minus 1, x plus 1. And then I still have that x plus 4. Now, because I'm solving, I'm going to go ahead. I'm going to split all of these up. This 3 I can kind of ignore because it's not an x. But I have a positive 1. I have a negative 1. And I have a negative 4. And those matched my graph. All right, moving on. I'm going to sketch. Now, sketch means I don't necessarily need to be perfect. So So I have a couple of hints here. I know that I'm going to be touching the x-axis because remember, zeros are where they actually touch the x-axis. I'm going to be touching the x-axis at -5, 1, and 4. And then I also have a couple hints here. These are called your domain and range. Now don't get scared by your domain and range. Whenever they talk about your x's are where you go right and left. So positive infinity means to the right, negative infinity means to the left. So this is just talking about to the right, this is just talking about to the left. And P of x is really the same thing as your y. Positive infinity means to the means up, negative infinity means down. So when you see negative infinity, we're talking about down. Negative infinity means down. All right, so let's put this all together. I know that I'm crossing at 1. I know that I'm crossing at 4. And I know that I'm crossing at -5. Okay, it doesn't have to be perfect. But one of the things I know is that when I look to the right, I know that my graph has to go down. And when I look to the left, I know that my graph has to go down. So what that means is that my graph has to start and end going down. Okay? So how are we going to make that happen? Well, let's see. If I go through here, okay, now I'm going to have a bounce. That's the only way that's going to make the beginning and the end go down. Okay? All right. The next question. Now this question seems very difficult, but actually it's a lot easier than it's going to look, because the first thing that I want you to do is to look at the denominators. Now there's a rule that your denominators are not allowed to be 0. So if you just look at this one, x can't be 0. So right away, I know that can't be this one, can't be this one, okay? And over here, I know that this can't be 0. So what number would make that equal to 0? 2. So I know that it can't be 2. So therefore, for this particular question, I know that it has to have no solution. Now, I also want to show you how to do this in the calculator. Okay, so when you do this in the calculator, you're going to go ahead and split it right down the middle, and you're actually going to put the left side into your calculator, and you're going to plug the right side into your calculator. And from there, you're going to look to see if any of the y's are the same. Okay, so this is my left side. And that's my right side. And when I go to my table, I'm looking for anywhere where the y's are the same. And if I look very carefully, none of them are the same, which is why there is no solution. Okay? All right, moving on. Number 6, we're going to do this both ways, but I also want to tell you that you can also do this one exactly the way that we did it, okay? So we are going to do this algebraically, which means by hand, but what's nice is that at the end, you have to check this anyway, so you might as well get the answer before you even do the problem so you know what you're looking for. And if this is a multiple choice question, you could do this right away and get your answer. So left side, right side. Let's look at the table. And I already see it. There's a 5 and a 5, so my answer's 6. Let's see if I see anything else. Okay, so see this 2 and this -2? They are not the same, so that's not a solution. All right, so it looks like my answer is going to be 6. So I'm just going to put x is equal to 6. All right, now over here, I call this the jewelry box method. So you want to unlock your jewelry box, but before you unlock your jewelry box, you want to make sure that it's alone on one side of the equal sign, which it is. So in order to unlock the jewelry box, you're going to square it. But whatever you do to one side, you're going to do to the other side. So when you unlock the jewelry box, it really just cancels it out, and nothing underneath changes. It just unlocks the jewelry box. Your jewels do not change. But over here, I have to multiply this twice, which is really just a foil or a box. So however you want to do it is fine. X squared minus x plus 1. Now from here, you want to move everything over. I like to call this my line leader, x squared. So I'm going to go ahead and move over my 3x. I'm going to move over my 7. And actually, you know what? Before I do that, let's go ahead and combine these two. So 3x plus 7. Whoops, it's very messy. X squared minus 2x. Okay, so now I'll move those over. Those are gone. Now I have x squared minus 5x minus 6, and now it's time to factor. Okay, I'm going to drop the first sign. A negative times a negative is a positive, and I'm looking for two numbers that multiply to 6 that add up to 5. So I'm going to choose 6 and 1 because of my signs, -6 plus 1, and the bigger number always goes first. So there's my 6, there's my -1, but remember when I told you that -1 didn't work? And there it is, there's your 6. All right, the expression is equivalent. All right, so for this one, I would definitely recommend something where you do your 10 stow x, okay? Now, if by any chance this is a free response question, which is actually very, very, very rare, okay? You would have to multiply. Now, I and I kind of acts like x times x. So x times x is x squared. So you'd kind of just multiply squish all of these together. And then you do the same over here. You'd squish all these together. So 3 times 6 is 18. I times I squared is I to the third. And then when you change these, I squared and I to the third, you can actually put those in your calculator using second dot. Okay, it's your decimal point down there. All right, so if you do I squared, it's -1. If you do I to the third, it's -I. So these are -1, -I. So I have 3a times -1 minus 18 times -I. So I'm really just going to put this negative in front, and that negative times that negative is positive 18. So we are right, oh, sorry, forgot the I. We are choice 3. And hopefully if we use the equivalent, which I would check that if I were you, you get the same answer. All right, the solution to the equation. So if you look at your multiple choice options, I see i's, I see radicals. So this kind of gives you a big hint that you have a a quadratic formula, okay? So the quadratic formula is given to you. It's x equals negative b plus and minus b squared minus 4ac all over 2a. And a, b, and c are going to be the numbers in front of x squared, x, and the last number. But be very careful, because if there's a minus sign, that counts as a negative, which in this case, there is none. So I'm going to set this up. X equals negative b plus and minus b squared minus 4 times a times c all over 2a. All right, now from here, you are not putting everything in your calculator. A lot of people think so. You're only putting what's underneath the radical. Everything else is going to stay as is. Okay? So the only thing you're putting is 3 squared minus 4 times a times c. And there's that negative, which is the whole reason why I have an I. Now 7, you cannot simplify. So we're going to just pull out that negative and make it an I. We're going to leave this. And a plus bi form wants us to take the bottom and split it up. So our answer is going to have a negative 3 over 4. And it says a solution, so it's just showing the plus. And it's going to have a I and a radical 7. So it's choice 1. Okay, number 9. The average monthly temperature, T of M in degrees Fahrenheit, over a 12-month period can be modeled by this equation. M is in months. What is the range of temperatures in degrees Fahrenheit? So range is really just another way of saying max and min. Okay? So in order to find your max and min, you are going to take your shift and you're going to add and subtract your amplitude. And don't use that negative. That negative is just there to tell us that we were starting at the bottom. So we're going to take 56, and from 56 we were going up 23, and from 56 we are going down 23. So if we add those together, the highest we're going is 79, and the lowest we are going is 33. Okay, so that is choice 2. Done. All right, number 10. We're graphing at least one cycle on the set of axes. So we're graphing a sine curve, and any time that you graph a sine or cosine, you are always breaking this up into 4 parts. The reason is because it came from 4 quadrants. Now the first thing that you want to do is start with your shift. So I'm going to go ahead and start with my shift. And now that I have that, I'm going to go ahead and break this up into 4 parts. And the only thing that you need to actually label is your period. Okay? Now my amplitude is 5, so I know that from here the highest that I'm going is 5, 1, 2, 3, 4, 5, and the lowest that I'm going is 5. All right, now let's find the period. This is B. So your period is equal to 2 pi over B. So 2 pi over 4. If we simplify this, we get pi over 2. And this is the only thing that we need to label. It's just the length of the curve. So I'm going to put that at the last tick mark. And now I'm ready to actually graph it. So a sine curve has 4 parts. Okay, I like to say that I'm a sine curve. I wake up and I'm right in the middle. I don't know what kind of day I have. But if it's a school day, I know that I enjoy being at school, so I go up. Halfway through the school day, I start getting tired. Okay, teaching, there's a lot of energy. By the end of the school day, I am exhausted. But I get to go home and see my kids, so I start going up again. So this is one cycle for a sine. And there you have it. Okay. Which expression is equivalent? Again, we have another equivalent. So if you want, you could do the store. For this one, though, I'm going to show you how to do it without the store. Now, I know that this is a little bit hard to see what it actually is, but it's actually a times, that 5 is not an exponent, it's actually a root. So this question is testing you on how to change a radical into a fractional exponent. So I like to think of this as if you are inside the party, you must have been at the top of the list. And if you're outside the party, you must have been at the bottom of the list. And anytime you don't see an exponent, it must be 1. Now from here, the rule is that when you're multiplying the same base, you're going to take these exponents and you're going to add them. So I'm going to take 1 plus 4/5, and I'm going to go ahead and change that, to a fraction, which is 9/5. So my answer is going to be a to the 9/5, which if you did the equivalent, I would check this if I were you, that would be the correct answer. All right, number 12. A study of the red-tailed hawk population in a given area shows that the population A of t can be represented by the function blah, 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 where t represents the number of years since the study began. In terms of the monthly growth rate, the population can best be approximated by this function. So here's the deal. The original t was in years, and now we want to go ahead and change that to monthly rate. So this is a very, very popular question, and what happens is that we need to take whatever's inside that and we need to change it. So the rule is that whatever's inside those parentheses, you're going to change, you're going to raise it to whatever the unit rate is. So if you're going from years to months, there are 12 months in a year. Now I also want to point out that if you're changing something, that 1.19 is being changed. If you look down here, that's not being changed. So I already know that 3 and 4 is not my answer. So now let's go ahead and put this in my calculator to see what my new number would be. All right, so it's looking like 1.0146, which would be rounded to 1.015. So by process of elimination, I know this is my right answer, but just so you know, also, you're never going to change your final exponent to a fraction. It always gets the new unit times whatever your t was. Okay. Number 13. The function blah 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 can be used to predict the temperature of a cup of hot chocolate in degrees Fahrenheit after X minutes. What is the approximate average rate of change of the temperature of the hot chocolate in degrees per minute over this interval? Okay, average rate of change is very, very, very important. I always tell my students that in order to find average rate of change, you need 2 points. And where are you going to get these 2 points from? Well, in this case, you have an equation. And because you have an equation, the only way to find these 2 points is to put this into your y equals. And if you have 0 and 6, the only way to find this is if you go and find it at 0 and 6. Okay, so let's go ahead and plug this into my calculator. Okay, so I have 90 times 0.86 to the x power. And don't get scared by the equation. It's going to look crazy. Don't worry about it though. Does not matter. And we are going to look at our table. And we have 0, 159. Okay, so we're going to need that. And we need 6. 105.411. 105.411, was that it? Yeah, okay, so there it is. So those are our 2 points, and you don't have to set it up like me, but for whatever reason, this is the way that I like to do it. All right, so 2 points. Once you get your 2 points, the equation is y minus y over x minus x. Okay, so I'm going to do y minus y over x minus x. So this is an x, this is a y, this is an x, this is a y. Be very careful, your y's are always on top. Minus 159 over 6 minus 0. All right, so 105.411 minus 159 over 6 minus 0, and I'm getting negative 8.9, which is choice 1. And there it is. Done. All right. One of the medical uses of iodine-131 is a radioactive isotope of iodine to enhance X-ray images. The half-life of this is approximately 8.02 days. A patient is injected with 20 milligrams of this, determined to the nearest day. The amount of time needed before the amount of iodine in a patient's body is approximately 7. Now here's the deal with this. You do not have to memorize this formula. This formula is on your formula sheet, and it looks like this. T over H. I believe it is a lowercase h, okay? Now this is your initial. Okay, so your initial is going to be 20. And this is going to be your final, which is 7. So when we plug this in, we want to know how long does it take to go from 20 to 7. With a half-life of 8.02. Now this is going to be logs, because logs is always when you're solving for an exponent. And logs always have 3 parts. They have a base, an exponent, and an answer. So in this case, that 20 is not doing anything for us. So we're going to go ahead and take that 20 and we're going to divide it over. So 7 divided by 20 is negative 446 575. Okay, now I have 3 parts, so it's time to put this into logs. Okay, so base goes on the bottom, then comes your answer. And the whole point of logs was to get the exponent by itself. Okay, so I'm going to go ahead and put this in the calculator, math alpha math. Okay, there is my base. What did I do? Oh, my bad. Hello. Okay, I totally did this wrong. 7 divided by 20. I don't know where I got that from. I apologize. Obviously, 7 divided by 20 is not a negative. Oh my goodness, people. Alright, so 0.35. Okay, so log 1/2, 0.35. Okay, so 1.5, and then because this is divided by 8.02, the opposite would be to multiply it. So whatever's in my calculator, I'm just going to keep, and then I'm going to go ahead and take that, and I'm going to multiply it by 8.02, and I'll get 12.146, and it says to the nearest day, which is 12. And there you have it. Okay, a cup of coffee is left out on the countertop to cool. The table below represents the temperature in degrees Fahrenheit of the coffee after it's left out for 2 minutes. Based on these data, we want to write an exponential regression equation to model the temperature of the coffee, and we want to round to the nearest thousands, which is 3 decimals. All right, so our exponential regression equations. This is where you want to go to Stat, Edit. And we're going to put in our information into L1 and L2. So let's go to Stat, Edit. If you have anything in there, you're going to highlight L1, press Clear, Enter, Clear, Enter. So L1 is 0, 5, 10, 15, 20, 25. And then we have 180, 144, 120, 104, 93.3, and 86.2. All right, and I would just give those numbers, a quick check just to make sure that you didn't make a mistake, because unfortunately, one number wrong will change your equation. Okay, so you have all these regressions. Sometimes they'll ask for a power. We're asking for an exponential. So you're just going to hit EXP-REG. You don't have to do anything. You just press calculate, and there's your equation. You're just looking for A and B, and nearest thousands is 3 decimals. So 169.136 and 0.971. So I'm just going to write those again. So Stat, Calc, EXP, REG, and then we're going to put y equals a b to the x, and then really this is acceptable, but you have to put this. So I believe we said 169.136 and 971. And there you go. Alrighty. A recursive formula you have to remember. So this is not on your formula sheet. Okay? And a recursive formula is 2 things. Thing 1 and thing 2. So if you look at choice 1, it only has one thing, so that's out. And if you look at choice 3, it only has one thing, so that's out. So what do I mean by one thing? Well, you need your first term. Okay? So this is your first term, this is your first term. But now we need to figure out, well, how do you go from 30 to 22 and a half? Are we adding, multiplying? So if I were going down by 10, my next number would be 20. So clearly that's not the answer. So I'm going to go ahead and divide the second term by the first term to see what my pattern is. So if I go ahead and do 30 divided by 40, it's 0.75, and 0.75 is equivalent to 3/4. So if you look here, there's 3/4, and this just means the term in front of it, so therefore 4 is the correct answer. All right, 17. John and Margaret deposit $500 into a savings account for their son on his first birthday. They continue to make a deposit of $500 on their child's birthday, with the last deposit being made on the child's 21st birthday. If the account pays 4% annual interest, which equation represents the amount of money in the account after the last deposit is made? So here's what's happening, okay? You have $500 the first year, okay? So how much money do you have on the second year? Well, if you are increasing this by 4%, if I just take $500 and I multiply it by 0.04, my next year, I don't have $20. So what happens is when you have a question like this, you want to add 1 to it. So I have $520 the next year. So this is what's called your ratio, not your rate. And what's happening is we want to know how much money we have all together. So what we're going to actually do here is we're going to be adding these together. So this is called a series. This is a geometric series. So this is a formula on your formula sheet. And this formula is your first term, 1 minus r to the n power over 1 minus r. And one thing that I want to point out is these should be the same, okay? So first of all, this is not it. This is not it. And I want you to look at these. They tried to trick you. Those are not the same. So the correct answer here is 2. That's what you would use to see how much money he'd have after 21 years. All right, inverse. So what is inverse? Inverse is to switch x and y. So instead of y equals, you have x equals, and instead of x, you have y. Whoops. So now that you have a new equation, you want to go ahead and solve for y. So we're going to subtract over 5. And we're going to write it like we read it, x minus 5. And because this is 4 times y, we're going to divide by 4. Now, I don't see that there, and that's probably because they're separating this 4. And when you don't see a number in front of x, it's 1. So you're looking for 1/4 x minus 5 over 4, and there is your answer. All right, number 19. Which value to the nearest tenth is an approximate solution to this? All right, now this always is asked. And whenever you see these two functions that are set equal to each other, this is a calculator question, which is awesome, but they only want the x value, okay? So when we plug this in, we're going to plug it into our y equals. We're going to use our calculator, but they only want the x, okay? So let's go ahead. We're going to plug this into our y equals. So the first one is 5 over x minus 3. And our next one is 2 times 1.3 to the x power. All right, so we're going to graph it. And I can see on mine that I have a solution right here. Now my calculator is a little bit different because all I have to do is just, hit it and it says intersect. I'll write the steps out for you. But if I look at the top left, I'm only looking for my x. So my rounded to the nearest tenth, it's going to be 3.9. So my answer to this is 3.9. Now the steps on your calculator are going to be second, trace, intersect. And then you're going to move your cursor. I like to call it the spider. Cursor to intersection. And then you're going to press enter 3 times. There you go. And that should get you it. All right, number 20. A veterinarian pharmaceutical company plans to test a new drug to treat a common intestinal infection among puppies. The puppies are randomly assigned to 2 groups. That's huge. Half of the puppies will receive the drug, and the other half will receive a placebo. The veterinarians monitor the puppies. This is an example to which study method? Well, they gave it away. When you have 2 groups that are randomly divided, that automatically is a controlled experiment. Done. The weight of the bags of pears at the local market averages, which also has another word, mean, of 8 pounds and a standard deviation of 0.5. The weights of the bags of pears at the market closely follow a normal distribution. Determine what percentage of the bags to the nearest integer weigh less than 8.25. So just so you know, a normal distribution means that you're dealing with a curve, and also means that you can use normal CDF, okay? So let's draw this first so we kind of know what we're dealing with. We have a mean of 8, and we are looking for less than 8.25. So I'm looking for all of this, and if I don't have a number to the left, I'm going to use a really small number, which is a negative. So in my calculator, and if this is not a multiple choice, you have to show work, which is to either draw it or to write the calculator buttons. And the calculator buttons are going to get our second bars, normal, CDF. All right, so let's go ahead and put all of our data in. So second bars, it's the second one, normal CDF. Now my calculator is a little bit different, but yours will say lower upper mean standard deviation. So your lower is going to be that negative number to 8.25. And then your mean was 8, and your standard deviation was 0.5. Now this is the decimal, but they want a percentage. So to change a decimal to a percent, you're going to multiply by 100. And they want it to the nearest integer, which means no decimals. So this is 69%. So I'm going to just fill this in to 8.25, 8.5, I got 0.69, which is 69%. And there you have it. All right, we're almost done. A public radio station held a fundraiser. The table below summarizes the donor category and method of donation. All right, we have to round to the nearest thousands, find the probability that a randomly selected donor characterized as a supporter, okay, here we go, given that the donation was made online. All right, so given that the donation was made online, was a supporter. And then we want to know, do these data indicate that the supporter is independent of donating? All right, so let's go ahead and do the first part. Given means out of. And when you talk about out of, that means that you're only talking about that specific group and you're talking about the bottom of a fraction. So what group are we talking about? We're only talking about the donation that was made online. So I'm going to go ahead and highlight the donation that was made online. So if I'm only talking about that group, that's the group that's going to go on the bottom. So I need to find the total of that group. So let's go ahead and add those numbers together. 1,200 plus 2016 is 3216. All right. So what I'm saying is that out of that group, now I'm looking for how many were supporters. There it is. Okay, now in this case, that fraction is correct, but we don't want the fraction. We want it to the nearest thousandths, which is 3 decimals. Whoops. So 1,200 divided by, okay, and 3 decimals is 0.373. And there you have it. That's 2 points. All right, now we have independent. There are 2 formulas for independent. You do not have to memorize them, but one of them is ABBA. And I like to say ABAT. This stands for table total. Okay? Now in this case, let's change ABA. So let's use supporter and let's use donate online. So let's use O, okay? So let's use support online is equal to support out of table total. So when this happens, it's always going to be 2 fractions, 4 numbers, and they are not going to repeat. All right, here we go. So I'm saying this is given. Out of the online supporters. Hey, we just did that, right? 3216. How many were supporters? Hey, we just did that. And on this side, I'm saying out of the table total. Well, in that case, my table total is everyone. So now I'm going to have to add up all of them. So 400, 1,200, 672 plus 2016. 4288. Okay. So 4288. Okay. So I'm saying out of everybody, how many are supporters? So where are my supporters? My supporters are over here. So I'm going to have to add up all of those, which is 1,600. Now, if I really wanted to check, let's circle the 4 numbers. I did 1,600, 4288, 1,200, and I also did this number over here, which was 3216. I used 4 different numbers, and they created a box, so that's good to go. Now let's check the left side and the right side. The left side we already did. The right side is 1,600 divided by 4288. Ooh, look at that. You could tell that and that are exactly the same. So, are they independent? Yes. And there you have it. All right, this is our last question. A supporting goods manufacturer is trying to determine if they should continue to produce multiple types of hockey pucks. The company surveyed 50 randomly chosen customers and asked them if they produced both game regulation pucks and lighter training pucks. Of those surveyed, 40 of them said that they purchased both types of pucks. A simulation that was run 100 times based on a survey resulted produced approximately normal results below. All right, here we go. Determine an interval containing the middle 95 of plausible values that estimates the proportion of all customers who would purchase both types of pucks from the company. This is a very, very, very popular question. This is your 95% confidence interval, which is going to be your mean plus and minus 2 times your standard deviation. They're always going to give your mean and they're always going to give your standard deviation. So you're never, ever, ever going to have to find it or calculate it or something like that. And the reason why it's 2 is because 95% is 2 standard deviations. Okay, so let's go ahead and multiply this. So 2 times 0.085. And then from there, we're going to go ahead and add and subtract it to this mean. So 0.795 minus, which is 0.625. Did they tell us how to round it? No, they did not. Usually they do, so just be careful with the 0.625. Okay, and then 0.795 plus 0.17, 0.965. So this is your 95% confidence interval. And if I kind of show you on the graph or on the normal distribution, 0.625 is probably somewhere around here. 0.965 is probably somewhere around here. So if you notice, you have about 95% that's within here. All of this is usual. Okay? Everything out here is considered unusual. Another word for this is statistically significant. Okay, so they might ask a follow-up question about something, and if it's on the inside, then it's usual. If it's on the outside, then it's unusual. All right, I hope you got something out of this. Good luck, study hard, and I will see you then.